In this video, I'll consider one numerical on Laplace transform. Find the Laplace transform of the waveform shown below. This is the given signal f of t, which is sawtooth signal, which is periodic in nature. Now we need to find the Laplace transform of this f of t. So here the given signal is periodic. So to find the Laplace transform of a periodic signal, instead of finding the complete signal, first we will consider one cycle of the signal. Let me consider one cycle of this periodic signal. So let this be a one cycle of periodic signal. I will call it as f1 of t. The complete signal is f of t. One cycle of signal I will call it as f1 of t. Here the period of the signal is t. Since the period of the signal is t, so when we observe this signal, here we can see that first there exists a ramp signal. So when there is a ramp signal, we need to find the slope of this ramp signal. Let me calculate the slope of this. So at this coordinates, the values are x1, y1. At this point, the coordinates are x2, y2. Here x1 is 0, y1 is 0. Here x2 is t, y2 is a. Let me calculate slope. So slope will be equal to y2 minus y1 divided by x2 minus x1. So y2 is a and y1 is 0 divided by t minus 0, that is nothing but a by t. The slope of ramp signal is a by t. So let me consider the first signal. So I will call it as, say, fa of t. So fa of t is a ramp signal of slope a by t. So I can represent this signal in terms of unit step signal as, I can write fa of t is equal to, slope is a by t, t u of t. When we observe this signal, the slope is stopped at t equal to t, but when the fa of t signal, this is continued till infinity. So we need to stop this fa of t at t equal to t. To stop this fa of t signal at t equal to t, we need to add one negative ramp signal at t equal to t. That is, let me take one more step signal, a ramp signal. I will call it as fb of t. That is, at t equal to t, I will add one negative ramp signal like this, of magnitude or slope minus a by t. So this, the value of this will become fb of t is equal to, this is minus a by t. It is delayed by t, so I can call it as shifted ramp signal, that is t minus t u of t minus t. So if we add fa of t with fb of t, the resultant signal will be like this. That is, if I add fa of t signal with fb of t signal, it will be like this. It appears like this. That is, when positive ramp signal is added with negative ramp signal, it will become like this. It is t here. So now, according to this signal, at t equal to t, the signal has become 0. So, but here the signal is continuing. So, we need to make it 0. So, now to make it 0, I will add one negative step signal at t equal to t of magnitude minus a. Let that be my next signal. So, my next signal is, we have fc of t. I will call it as fc of t, which is a negative step signal which is added at t equal to t of magnitude minus a. Now, if I add fa of t with fb of t plus fc of t, so here the signal will become like this, because earlier it was like this. The positive step signal of magnitude plus a will be added with minus a, it will become 0. So I can represent fc of t will be equal to, so here magnitude is minus a, that is minus a u of t minus t. Now let me represent f1 of t. Therefore, I can write f1 of t will be equal to fa of t plus fb of t plus fc of t. That is, fa of t is, we have a by t, tu of t, that is a by t, t u of t. We have minus a by t, t minus t, u of t minus t, and we have minus a, u of t minus t. Now let me take the Laplace transform of this f1 of t, that is Laplace transform of f1 of t. So the Laplace transform of f1 of t is f1 of s will be equal to Laplace transform of this ramp signal is, it is a by t into 1 by s square minus Laplace transform of this shifted ramp signal, that is minus a by t e power minus ts into 1 by s square minus the Laplace transform of shifted step signal, it is e power minus ts into 1 by s. So this is the Laplace transform of one cycle. Now to find the Laplace transform of entire signal, that is f of s will be equal to 1 upon 1 minus e power minus t into s into f1 of s. So here t is period of the cycle. Here t is period of the signal. So in this case, the period of the signal is t itself. So therefore I can write f of s is equal to 1 over 1 minus e power minus ts into f of f1 of s. So f1 of s is nothing but a by t into 1 over s square minus a by t e power minus ts into 1 over s square minus e power minus ts into 1 over s. So this is the Laplace transform of given waveform. Thank you for watching.